6.3. Well, suppose you have this question. Question says, find the volume of the solid obtained by rotating about y-axis the region bounded between y equals to 0 and y equals to 2x squared minus x cubed. Okay, let's take a look at the graph first and see if we can analyze this. Here we have our x-axis, we have our y-axis, then the graph 2x squared minus x cubed. It's almost like this. And we start taking this between y equals to 2x squared minus x cubed and y equal to 0. And then we try to take this region and just rotate that about y-axis. Taking this and start rotating this about y-axis. Okay, well, taking this guy and start rotating this. Graph is not that hard to visualize, but the cross section, what should we do with the cross section? So if I take a cross sectional, how do I find the area? I'm interested in finding the area of the cross sectional. What is this area? Okay, remember that in one of the examples that we tried to find the volume rotating about y-axis, we use this formula that we say, hey, the integral c to b, a of y, dy, and a of y was the area of the cross-sectional, and we wrote everything in terms of y. It is y equals to 2x squared minus x cubed. It means that we need to isolate x in terms of y. So we need to isolate x and write it in terms of y. But how do you isolate x? Well, instead of doing that, we can use the method of cylindrical shells that say, hey, the volume, so cylindrical shell, the volume can be written as the integral of 2 pi x f of x dx. It says, hey, you can convert this formula into 2 pi x f of x dx, cylindrical shell. This is shell method. Okay, let's try apply this formula and find the volume. The volume is equal to the integral 2 pi x, okay, just copy down 2 pi x, f of x, which is 2x squared minus x cubed dx. And my x is bounded between, so I need to find 0 to whatever that number is. So if you set 2x squared minus x cubed equal to 0 and factor out x squared, you get 2 minus x equal to 0. So x is 0 and x is 2. So my x is bounded between 0 and 2. So the volume is equal to the integral 0 to 2 pi x. And you can just write 2 pi outside the integral and distribute x here. You get 2x cubed minus x to the 4 dx. So volume is 2 pi. Here you get 2 over 4 x to the 4th minus x to the 5th divided by 5. X is bounded between 0 and 2. Again, I'm not worried about 0. I'm just plugging 2. And if you simplify this, you get 16 pi over 5. So cylindrical shell method says, hey, instead of using, sometimes it's difficult to write the integral or find the area using the function isolating variables. So we can move on and define a new method, use a new method that makes life much more easier for us. This method, this way that we write the formula y equals to v is equal to the volume is the integral, definite integral, so let us write down to b or 0 to b, or depending on what the boundaries are. In this case, since we are using 0, starting at 0, let's just write down a to b 2 pi x f of x dx. So instead of using the area, we're using the circumference. Remember the formula, 2 pi x and then f of x, circumference times the height, and we are adding the areas that we have, then using the Riemann sum, taking the limit, we're defining the volume. Let me write down another example. So when we are using cylindrical shell method, know when to use x, when to use y. Suppose the question says, hey, find the volume